Students, motion is common to everything in this universe. We run, walk, and ride a bicycle. Even when we are sleeping, air moves into and out of our lungs. Blood flows in our arteries. We daily see leaves falling from the trees and water fall down from a dam. Birds flying in the air, aeroplanes flying in the air, vehicles moving on the road. So, motion is common in this universe. In this chapter, we are going to learning how to describe motion of an object. To describe motion of an object, we are going to understanding the concepts like position, distance, displacement, velocity, and acceleration. With all these concepts, we are going to building three set of equations of motion which can accurately describe motion of an object in this universe. Shall we do it? Students, in this class we are going to learning what is path length and displacement. Motion is change of position with time. To describe position, we need to use one reference point, three mutually perpendicular axes and a clock. We can call these three mutually perpendicular axes and a clock as frame of reference, simply reference frame.
Sir, I can simply say position of my pen like it is in my hand and not moving to anywhere. Then why do I need something like a frame of reference, sir?
Good question, Adya. Students, do you all agree with Adya's description? Adya, your description may valid to you, but a person from another planet will say that your pen is in your hand, but it is moving due to the motion of the earth. So, your description is invalid to him. Adya, your description is valid from your perspective, and description of a person from another planet is also valid from his perspective. So, to give accurate description, we should have to mention from which perspective this description is given. Then, anybody from anywhere in the universe will accept your description of object. To give valid description of motion of anything, we use frame of reference. Abhi, can you help me? Go there and stand still. Students, imagine Abhi's location as a reference point. We can say this reference point as origin. We have full freedom to choose origin anywhere in the space depending on our experiment. Now we should imagine three perpendicular lines as x, y, z, horizontally, vertically, back and forth respectively. Then we take right side direction, upward direction and front directions as positive directions, and left hand side directions, downward directions and backward directions as negative directions. Then we give appropriate numbers to each axis. These three mutually perpendicular lines are called coordinate axes. Abhi, can you give me my location using your newly built coordinate system?
Sir, your location is 20, 19 in my coordinate system, sir.
Good, Abhi. Now, Abhi is accurately describing my location in this universe. Likewise, any object's location is accurately described by Abhi using his coordinate system and origin. Now, I am providing a clock to the Abhi. The set of clock and coordinate system is called frame of reference. Now, Abhi is capable of doing any experiment of an object in this universe. If one or more coordinates changes with the time, then we can say the object is in motion. Otherwise, we can say that it is at rest. The description of an event is depends on reference frames chosen for the description. For example, if you say the car is moving on the road, it means the car is moving with respect to the reference frame attached to you or the ground. But the person sitting in the car will say that the car is not moving anymore with respect to his reference frame. To avoid complexities, let's confine ourselves to one dimensional motion in which only one coordinate is changing with time. Abhi, can you showcase one dimensional motion in your coordinate system? Students, now we are going to discussing what is path length and displacement. Arjun, choose 3 random locations along x-axis. Now Abhi is at origin. Abhi, can you move from your origin to P, then Q and R? The total distance traveled by Abhi in this case is called path length. Adya, can you tell me path length of Abhi?
Sir, his path length is OQ plus QR is equal to 18 meters.
In some situations, we don't want his entire path length. We just want to know how much he traveled from his initial position. Can anybody tell me how much he traveled from his initial position in his journey?
Sir, he moved 18 meters, sir.
Sir, I think he moved 4 meters, sir.
Wow! Well, Adya, this is his initial position at a time t is equal to t1, and that is his final position at a time t is equal to t2. He moved from initial position to final position in certain time period. To know how far he moved from his initial position, we just need to subtract his initial position from his final position. Then we got nothing but displacement, which explains how far he moved from his initial position in his journey.
Sir, what is this minus sign, sir?
Good question, Abhi. The result of displacement will give us 2 types of informations. The numerical number 4 meter tells us that we moved 4 meters from your initial position. This numerical number is called magnitude. The minus sign will tells us that the direction of your journey from your origin. In your case, the negative sign will tells us that in all possible directions from your initial position, you moved along negative axis. In our coming classes, we mostly deal the quantities, the physical quantities which have magnitude and direction, like the displacement. So students, that's about these 3 concepts: displacement, path length and the coordinate system. I hope you all understood these 3 concepts very well. To check how much you understood these 3 concepts, I am going to conducting a game. That's it. Are you ready to play the game?